So let's study the Delta-Wye for a second, and let's study a few aspects of the Delta-Wye. Okay, so our Delta-Wye starts at, let's say, 35 or 50 kV, right? It drops to 480 on the mutual inductance, and then it goes to 240. So all this is 240. So what we have to remember now on a Delta-Wye sequence is, what is this single phase? And we'll analyze the three phase. So first, let's do the single phase Delta-Wye. So I'll show you exactly what this single phase is, right? The single phase is this. So you have a delta. I'm going to kind of ignore the inductors for a minute because I don't really want to get into that. But let's ignore the inductors and just draw a single phase delta. Okay, and so now we have a plus 240 here, and obviously a plus, and we can kind of put the inductors in here. Okay, and I'll just put the inductors in just like that. Okay, and then obviously a plus 240 here. Okay, now this is a single phase. So what happens in a single phase is that it comes directly out of the delta circuit, right? So instead of going to a Y circuit, there's really no reason to do that. So what happens is, what you're going to do is split this delta line in half, okay? And we're going to go like this, okay? And then this is here, here. So if you split it in half, this is 240 volts, this is 240 volts, right? And this is single phase. I'm sorry, this is not 240, I apologize. This is, let me rewrite this again. Okay, this is 120 volts, and this is 120 volts, right? So this is a single phase 120, 240. So this would be a single phase. And the utilization for single phase is usually residential. Okay, so this is a single phase, and that's how we get 2 voltages in the house. You want 120 in the house, plug, and we get a 242 in the dryer. 242 is relatively the same, right? There's not much difference. Okay, now we can get into the other one. So here, and here. So this is our delta circuit again, okay? And in our delta circuit, we're going to see how it connects to the Y circuit, right? So this is going to be 240. Okay, and what we want to do, again, we'll draw the little inductors in. We'll draw the inductors in and draw the inductors in. But in a Y circuit, it's going to be 208. How do you get a 208 out of this, right? You really, it is a little more difficult to get. So this concept is called the Highleg concept, as such. And the Highleg concept is, we take the Highleg off the delta, okay? And this is obviously our Y. So what do? We want a 208 across here. I got to grab a 208. So what I do is I go from point A to, let's say, halfway here, right? Just like we went halfway on the single phase, we're simply going halfway on the three phase, and we're simply going halfway here. So this should be half. So I need to draw it halfway. So this halfway mark, right, this is really not a straight line. This is obviously a 30-60 triangle, right? So this is going to be obviously an angle of 30 degrees, and an angle of 60 degrees, and you're going to have an angle of 90 degrees. So based on the 30-60-90 triangle, what you're going to get is, you're going to get a 208, right? So basically this right here, we're going to call this X, okay? This X is equal to what? From here, measurement is going from here to here. Okay, so the voltage from A to B is 240. So we can write the following. VAB is 240 volts. Okay, V2, we're going to call this, let's call this at point X, whatever you want to call it. V to X, right? V to X is, VAX is 208 volts. How do we get that 208 volts? It's basically in the triangle formation, right? It is 240, right? It is, excuse me, just one second. It is 240 times the square root of 3 divided by 2. So let's just take out a calculator real quick. I'm going to turn on a calculator just now. Turn it around. That'd be 240 times the square root of 3 over 2. Okay, so let's do that. Say 240, all right, times, and the square root of 3 is 1.76. We can just go second square root 3, close, divide by 2. And I get 207.8, which is roughly 208 volts. Okay, there's my 208 volts. So therefore, from here to here is 208. So therefore, from here to here is 208 volts. Okay, so this is your line voltage. Line voltage is 240 line voltage, or you can call it 480 line voltage. It goes to 240, and now you're getting A to X. Okay, so this is the 208 going off the Y. So your Y is connected in this manner. Okay, I'm sorry, from here to here is your Y. Okay, now in your Y208, you need, how are you going to get a 120 out of here, right? So the 120 that's here, and I'm going to do it in blue, is 208, right, divided by the square root of 3. So you go here, 208 divided by second 3. Sorry, hold on. 208 divided second 3. There we go. Let me do that again one more time. Second there we go. And there's your 120. Okay, so this is the plug for 120 on a 3-phase. So this 3-phase, so this is a single-phase residential, okay, here, but this is our 3-phase. Another way to write it is 3-phase. And 3-phase is used for industry. And that's where we get our 3-phase in our buildings. This is how we get the power in our house. Okay. There's one more example I want to cover. And that example, okay, is the special case of your 277 parking light. How do you get it? Well, instead of dropping the voltages previously in the two words, instead of going 480, 240, 208, so in a single phase is very straightforward. You go 480 to 240, 240 straight to 120, no problem. In a phase, you go 480 to 240, 240, Highleg, 208, right? 208, then you have 208, which you get from square root of 3 divided by 2. So basically this is, if I were to rewrite this, this is 240 divided square root of 3 over 2. This is where we get our 208 from. And then our 120 is simply take this number and divide by the square root of 3. However, in our special case on the parking lights, it's a 480 delta straight coming out, okay? And our 480 delta is basically here, and we go straight out to 480, not a Highleg. Highleg is different. So 480, and then the 480 we get a 277 off the Y. And the 277 off the Y are your parking lots.